Great morning, everyone, and welcome back. Today we're finally going to put all of our convergence testing to use, and we're going to define power series. Power series is kind of like a polynomial, except instead of a finite number of terms, a finite degree, it has an infinite number of terms. And each term, as I've written here, is a power function. So let's look at what I've written here. X is a variable, and each term is a power of that variable. X to the 0, x to the 1, x squared, x cubed, etc., multiplied by some coefficient, c0, c1, c2, c3, and these coefficients depend on n. It depends on the position in the series, which term it is. So a power series is just an infinite polynomial, powers of some variable x, and each power of x has a coefficient, which is usually going to be given by a formula defined by n. More generally, though, if you don't want to have just x to the n, you can have x minus a to the n. You can just take a horizontal shift of those x to the n's. We call such a series a power series centered at a, or about a. And I'll have you note that the power series up here, Cn x to the n, is just a power series centered at 0, at a equals 0. Defining a function f whose values are given by this power series, f of x is the sum of Cn x minus a to the n, so you plug x in and you evaluate the resulting series, is going to put our convergence test to work. Because to define a function, you need to know its domain. And to know its domain, you need to know for which values of x is f of x defined? Which values of x can I plug in to this series and get a value out? i.e., when is f of x a convergent series? For what values of x does f of x give a convergent series? The function will be defined when f of x is convergent and will not be defined when f of x is divergent. Before we get into the shape of the domain of a power series, let's look at an example. Let's consider the function defined by a geometric power series centered at 0. So just the sum x to the n. Each coefficient here is equal to 1, so all of the cn's are equal to 1 in this example. Now let's ask ourselves a question. For which values of x is this function f of x defined? That is, for what values of x is the series that results a convergent series? To get an idea of what these two questions mean, why don't we plug a couple values in? For example, what's f of 0? Is f of 0 defined? Is 0 in the domain of this function or not? Well, if I replace the x with a 0, all I'm doing is adding powers of 0 together, which I hope you believe is equal to 0. So that converges. That means that f of 0 defined. 0 is in the domain of f. So anything that I plug into f that results in a convergent series, 0 does because it results in the series that just has a bunch of zeros added together, that's going to be in the domain of the function that I've defined. Let's try another value. Let's try 1/3. So that means all I'm doing is I'm replacing the x in that expression with a 1/3. So it's 1/3 to the n. Now, since this is a geometric series with r is equal to 1/3 less than 1, this converges. In fact, it converges to 3/2 if you use the formula, but I don't care right now. All I care is that it converges to a value. I plug in 1/3 into this function, and it gives me the series 1/3 to the n. And since that's a geometric series with r less than 1, it converges. So f of 1/3 is defined. 1/3 is in the domain of f. So things that I plug in that result in a convergent series are in the domain of the function that I've defined. Let's plug in one more. F of 3/2. This results in the series 3/2 to the n. This is also a geometric series, except now the ratio is bigger than 1. So this is still a geometric series, but now the ratio is 3/2, which is bigger than or equal to 1, so it diverges. So since it diverges, it doesn't have a value. It's not defined. F of 3/2 not defined. 3/2 not in domain of F. So things that I plug in, meaning replace the x with the thing I've plugged in, that result in a convergent series, give me things in the domain of that function. Things that result in a divergent series are not in the domain. Before we finish this example, I do want to make a quick note that the center is always in the domain of a power series. So if I have a power series, a function defined by a power series, centered at A, then A is in the domain of F. Guaranteed. Because F of A is just going to be x replaced with A. And when you replace x with A, you get A minus A, and you're going to get 0. So the center is always going to be in the domain. In general, what is the domain of this power series? In general, x is in domain of f of x. So this is just the geometric series with ratio x. If x is less than 1, because what's going to happen is I'm going to plug in a number and it's going to result in a geometric series with ratio less than 1. And x is not in the domain of f if x is bigger than or equal to 1, because it will result in a geometric series with ratio at least 1. We saw that the function defined by the geometric power series centered at a equals 0 with coefficients equal to 1 converges only if the absolute value of x is less than 1. What form do general power series have, their domains? Are they all ranges, like that example? Or is it possible that they converge for every possible value of x? Is it possible that they converge only for one value of x? Well, yes. And in fact, these are the only 3 possibilities. So for a given power series centered at A, here are the 3 possibilities for its domain. 1. F of x converges only at x equals A. We know that every power series converges at x equals A because you plug A in and you get a series of zeros. But it is possible that that's the only value that the series converges for. Second possibility is that f of x converges everywhere. So it converges for all x in the real numbers. So no matter what value I plug in, I get a convergence series. That's a possibility. Third possibility is that you get some range of values, like we did in the first example, that the series converges for. And we say that f of x converges for values of x that are close enough to A. And what this means is that there's some value, some cutoff for how far away you are before and still remain convergent. So there is some positive real number such that 1, if x minus a less than r, then f of x is convergent. So if I am within r, if x minus a is less than r apart, then you have a convergent series. And if you're too far away, if you're bigger than r, if the distance between x and a is bigger than r, then f of x is divergent. Okay? So these are the three possibilities for the domain of a function defined by a power series. Defined only at one value, defined at every possible value, or defined on some range of values where the range is given by how far away you are from the center A. And I do want to make a note that in number 3, if x minus a is equal to r, so if they are exactly r apart, you need to do a test for convergence to see if it converges there. The r in this definition is called the radius of convergence. And the domain of f, which is the set of all values x that make the series convergent, is called the interval of convergence. Also known as IOC. So the radius of convergence tells you how far away from the center you can be while still remaining convergent, and the interval of convergence is going to be the set of all x values that make the series convergent. So for situation 1, the radius of convergence is 0, and the interval of convergence is just the value a. So a is the domain, and you can't be more than 0 away from a and still remaining convergent. So nothing else is convergent. The distance from the center is 0, which of course is only a. For situation 2, we say that the radius is infinity, and the interval of convergence is r, or negative infinity to infinity. So r being infinity means, yes, the center is convergent. If I plug a in, I get a convergent series, but I can be infinitely far away from it in either directions. So any real number. And number 3, r is equal to, well, r, the value you find, and the interval of convergence can take one of 4 forms. And we're going to look at an example of these 4 forms. So either of. 1, you can either just be a minus r to a plus r. So that's a in the center. Go r to the right, r to the left, and that gives you your interval of convergence. So it's possible that a in the center, and you go out r in each direction. That's going to capture all the convergent values. But it's also possible that the endpoints are convergent. Remember, part 3 doesn't tell you anything about when x minus a is equal to r. And it's possible that only one of the 2 endpoints is convergent, and the other one is not, and either of them could be it. So if you have an interval, if you're in situation 3, you need to test the endpoints to see if it's convergent at the endpoints. It's definitely divergent outside that interval, because that's the definition of radius of convergence. But you need to test the endpoints. And we're going to look at examples of all 3 of these situations.